So let's look at our first lesson today. Our first lesson is 2.6, deal with ratios and proportions. Now, as far as the definitions, don't worry about copying those down. You should already have those in your vocab. Those are two of your terms. But thought it would be beneficial for us to go ahead and have those up there to start our lesson off. Okay, so when we talk about ratios and proportions, first off, we have to understand the concept of what a ratio is. A ratio is a comparison of two numbers by division. Multiple ways that we can write a ratio. Of course, we can write them using colons. We can write them using the word to. We can write them as fractions. Okay, so once again, several different ways that we can write a ratio. But very simply, it is a comparison of two numbers by division. Okay, but then we look at a proportion. Okay, as far as a proportion is really a type of an equation. Okay, it's a type of equation in which it's stating that two ratios are actually equal to one another. So on the previous page, we did have a proportion there because we had two ratios which were equal to one another. Okay, so as we looked at, there's two different ways that we can determine if we actually do have a proportion. We can simplify, or we can use cross products. Now, I'm going to give you an example here in which you actually have to use cross products in order to determine if you do have a proportion. Okay, since we do have a decimal here, we really can't simplify, so we are going to use cross products. So in using cross products, very simply, once again, what we're going to do, we're going to take the opposite, numerator and denominators, and we're going to multiply those together. So on this one, we could say, well, we got 8 times 3.5. But then we also have 14 times 2. Okay, so when we multiply those together, we should get the same number, which is 28. So yes. Okay, this one does form a proportion. So once again, anytime you get the same exact number, whenever you're using your cross multiplication, that does form a proportion. Okay, I'm going to let y'all try this one. With these two ratios, would they form a proportion? Yay or nay? Is this a proportion? I heard a yay. I heard a bunch of nays. Hey, you sound like a bunch of horses or something. Okay. All right, so yeah, this one, yes, would not form a proportion. Okay, why would this not form a proportion? Ben? Don't get the same thing. There you go. That's right. Good answer. Okay, so because when we cross multiply here, you should get 0.6. Okay, and you multiply the 0.3 times 2. And then for the other one, 1.5 times 0.5, we get 0.75. So yeah, we don't get the same thing, so this does not form a proportion. So of course, no, this is not a proportion. Okay, so that is when we are trying to figure out, do we actually have a proportion? Now the next thing we're going to look at is finding the missing number within a proportion. So here we actually do have a proportion, but now we're trying to figure out what that missing number is. Now there's a couple different ways that we could do this. What is one way, like in this particular proportion, what's one way we could figure out what x is equal to? Natalie? Okay, we could, good. Okay, so we could make those equal. Okay, find the least common denominator. So in this case, what would that be? 10, right? So we can go ahead and rename that, and that would give us what our answer would be for x. Okay, what's another way we could do that? Cross products, is that what you're saying? Okay, yeah, we could use cross products. 10 times 3 we get 30, and 5 times x we get 5x, and then we're going to divide 30 divided by 5. Okay, and that would also give us 6. Okay, any other ways we can figure that out? Emma?
You could see that 10 divided by 2 is 5, and 6 divided by 2 is 3.
Yeah, we could look at that and say, well, we got 10 and 5. 10 is divisible by 5, so we got 10 divided by 5 is 2. And that's what we're going to use in order to, that's a factor we would use with 3. 2 times 3, in which you get 6, so 6, which would be our solution. Okay, that would be our answer, and actually to form a proportion. Okay, good. Okay, now what about whenever we actually have an expression? Okay, now we actually have an expression in one of our numerators here. Okay, the x minus 2. So how would I go about solving this portion? Caroline?
Multiply by 14, cancel the portion out, and then
I'm sorry, say it.
multiply by 14, and then it'll cancel the 14 out,
Gotcha. Okay, good. Yeah, that's one way we could do it. We multiply by 14, cancel out that 14. Now we got the x minus 2. And we can multiply by 14 on the other side as well. Excellent. Good. Okay, what's another way we could do that? Emma?
you could use the multiply method, and it would end up with 7 times x minus 2 is equal to 8, and then you solve it as a proportion.
There you go. Yeah, we could also use that one too, where we use our cross multiplication or cross products and multiply. Now, this is the thing. If we use that method, cross multiplication. When I multiply 7 times x minus 2, how am I going to do that? Yeah, distributive property, right? Okay, so now I'm going to distribute 7 times x minus 2 is equal to 14 times 2. Okay, distribute the 7. Okay, now we got that two-step equation. Okay, in which we get our solution, which would be equal to 6. Okay. Paul? Yeah, like 250. Yeah. 250. 250. Yeah. Yeah. Thank you. All right, any other questions on that one? Comments? Okay, I'm going to let y'all try this one. Okay, determine what would be the solution for x on this one. All right, y'all, let's go through this one. Now, a couple different ways that we could do this. Of course, we could use cross products. We could do the way that Carol Ann talked about on the last problem. We could start off here. Now, if I were going to do it that way, which number do you think might be a little easier to multiply by? Which one? I think the 4. Okay, why do you think the 4 would be? So, just to make sure this is what you're saying. So, like this. So, what you're saying? Okay. Now, if you do it that way, though, are you going to be left with a denominator?
Yes.
So, when you cross cancel over on the left, okay, we're going to have a denominator if we do it that way. Okay. You think it might be a little easier to work with the problem when it doesn't, when we've eliminated the denominators? Okay, what if we did this? Now, are we going to eliminate those denominators? Okay. Now we're going to eliminate those denominators. And, okay, when we divide by 4, of course that goes in once, and then we're left with 3 here. So now what you'd have is 2x minus 4 is equal to x minus 8. You still got your 3 there, so you'd have to distribute. Okay, once you distribute that, then you solve for x. So that's one method. That's one way of doing it. Now, when you do that, though, okay, this one's in the previous problem as well. It's pretty easy because the larger number is divisible by the smaller. So we can do that, and we're going to eliminate those denominators. Now, of course, we can also use cross products. Okay, and using the cross products, in which we'd have 12 times x minus 8 is equal to 4 times 2x minus 4. Okay, then we distribute. Okay, so once we do that, now we're going to move those variables to one side. Okay, so we get 4x is equal to 80 and 20, okay, which would be our solution. Okay, all right, any questions on that? William?
What if the denominator
this assignment, give you a little bit of time to work on it, and then we'll cover our second lesson. Page 115, problems 10 through 32, do the evens. And then also 37 through 39, you're going to do all of those, and 55 through 57, do all of those.